Next, talk about your vision of becoming the AWS of networking.
Really, same sort of idea.
Hello, everyone. You're listening to Angel Nears, the podcast. Angel Nears is a Silicon Valley community for startup builders where experienced operators share their firsthand knowledge on how to build and scale startups. I'm your host, Oleg Kujakov, and our guest today is Ryo Koyama, a co-founder and CEO of Remote IT, a company which helps telcos, ISPs, and enterprises to secure their internet connectivity. Today, we're talking with Ryo about the finer points of securing IoT devices and accessing cloud resources while building a better internet. But before we get into that, Ryo, welcome to the show and thanks for joining us.
Hey, thanks a lot. And although we love the fact that you can talk about it as remote IT, we actually say remote it because that's what we think you want to be able to do with all your stuff, be able to access it remotely.
Okay. Can you tell me about remote IT? I feel like that's a good place to start this conversation we're about to have.
Okay, yeah. Like I said, the company itself, the name is remote it versus remote IT. So it's not always obvious, I suppose, in that way. But sure, the company itself, maybe the simplest way to think about it is we're trying to go beyond VPN. So virtual private networks is probably the way that people think of private networks. And obviously, everything is networked today because of the internet. And more people are becoming aware of what privacy means. And every day you hear about things like hacks. And so what we did is we took a certain amount of knowledge that we have about networking and we've built out a service that we think is the right sort of approach for what you're going to need in the internet age for managing private networks.
Unpack that. So talk about that approach and how is it different than, what we've been doing in the past?
Well, the interesting thing about the internet itself is it's built around these protocols. Everybody's probably heard the terms TCP/IP, and these protocols were invented about 40 years ago, and they were really invented to connect one building to another, and that was very useful. And they're very open, and obviously the whole internet is based around that. But because they're open, they're really not well suited for how people want to use private networks. So if you think about how people think about private networks, well, usually what that means is there's an address range, something they call the subnet. Everybody probably at least is aware of like a 10.0.0.1 or a 192.168 address. And the only reason those addresses existed was because when they first started the internet, they just didn't have enough addresses. So you needed other ones. But over the last 40 years or so, people have started to say, oh, those are private networks. And they're not really private networks, they're just smaller public networks. And so when you hear about a hack, usually it's because someone broke into that private network and everything on that network is open. So it's easy to scan them, find them, detect them. One way that we like to think about the analogy is everybody has a deadbolt on their front door. And in theory, that gives you security and privacy. But the truth is, what really gives you security and privacy is your zip code, because it's more of where you live that protects you than the deadbolt that you have on the door. And the way that the internet or any kind of network protocols work today is that if you have an IP address, whether it's a private IP address or a public IP address, it means you're discoverable. And so, going back to the door analogy, imagine you've now put your front door in the worst neighborhood in the world. So, it doesn't matter how good your lock is, someone's going to break in. And that's what's happening with all the network devices that are out there today because all their doors, in some way or another, are right in the bad neighborhoods.
That's really interesting, and I'm really excited to continue unpacking it. I feel like we got a very nice elevator pitch there. But I like to start these interviews, well, however feels right. But we got the elevator pitch. Let's hear about you because I'm sure you have an interesting background. Tell us a little bit about yourself and maybe how you got interested in this problem of VPNs and internet security. I'm sure there's lots of problems you're interested in, but just tell us a little bit about yourself.
Well, my degree is in fluid dynamics, which is obviously not terribly related to what we're doing here today. But when I was in school, I was just fortunately enough to have been dealing with computers at an era when all the college graduates out of engineering kind of knew more about computers in the workforce. So we had a lot of different options. And I was fortunate enough to kind of get into product management at the time because I'd worked as a CAD designer. Along the way, I really did, I guess, embrace the idea that there's a lot of technology that's very interesting, but how do you make that more approachable? And back in my 20s, I was really, I found that whole concept of kind of universal technology pretty interesting, and so I got an opportunity to work with Mark Weiser, who was the chief technologist at Xerox PARC, and he was the person who coined the idea of ubiquiting, which is that soon computing would be available everywhere and you wouldn't really know it. And so I was working with him because he was trying to spin a company out. And ironically, at the time, I sort of had this idea that TCP/IP was going to be the winner, and so I wanted to be able to take that and make a silicon solution out of that. And so, when I was working with Mark to spin out this company at Xerox PARC, we kind of joked and said, well, unless I get funding. And then ironically, I managed to get funding. And so me and a few other folks, we did the first silicon, the semiconductor implementation of TCP/IP. And we licensed that out to folks like Sony, Toshiba, Agilent, and it was used in a lot of early devices that today are called IoT type of devices. In fact, when NTT Docomo did the first TCP/IP mobile network, which was called iMode at the time, I think it was deployed in 1999, many of the edge devices actually used chips based on our technology to connect to that. And so from that, what we really learned is that, wow, a lot of devices are going to get connected, but really it's not just the connectivity that matters. What really matters is you're going to have to worry about how do you manage and control those devices, because conventional networking really doesn't match that way. And so that company was called iReady. NVIDIA ended up owning it. In fact, a reasonable chunk of the team, I think, is still at the center of their data center activities. So, because obviously they've moved a lot into kind of networking itself. But after leaving there, we were starting to think more and more about, gosh, what kind of approaches might make more sense? And we came up with this idea that, well, what you really want is you want to be able to offer networking as a service. And this is before even AWS existed. And so we invented a technology which essentially allows you to take any TCP/IP stack and make it addressable. So, like you, Oleg, you can say, hey, these are my devices. And so now I want to have my own private internet and I want to be able to access those, and only myself and people I allow to have access to them can get access to that. And that's sort of what our service does. It essentially allows you to create your own internet that only you decide what devices and what people can participate in.
And how long has this kind of idea of networks as a service been around or even existed?
It's interesting. It's still emerging. Networking today, for whatever reason, is still very, very, very hardware centric. People still, if you want a network, guess what? There's full expectation that you're going to buy a piece of equipment from a networking vendor. And I think that's a big part of the challenge that's out there today, is that if somebody says, well, what about a network? The first thing they ask is, well, where's the router? Because that's making your network. But that really doesn't work, because more and more it's not becoming a reasonable way to go. And what's interesting is that, obviously the single largest cloud vendor in the world is Amazon. But if you're using Amazon today, you still have to self-manage all your network configuration. If you have an Amazon instance and you want to be able to access to it, you need to have a global IP address and an open port, which ironically creates a unexpected vulnerability for you, even though you're in the cloud. Now, ironically, of course, if you're using Remote It for AWS access, then it solves that problem.
Can you talk more about the mission of Remote It? I'm sure you've gone through kind of iterations and you've grown as a company, but like today in March of 2021, what's the mission of the company?
The mission of the company really is to make networking as easily available as cloud computing is. Right now, I'm old enough to remember having to source servers, having to source a co-location facility, having to staff an IT staff to manage my data center. Today, no one would ever do that. You just go to AWS and spin up an instance. That paradigm does not exist for networking, right? If you want to still set up something, or if you want to deploy a field of devices, you got to buy a lot of networking equipment. You still got to have somebody manage the VPN. And it makes no sense to do that, because networking is arguably a much worse problem of managing, because you can go buy a $500,000 VPN tomorrow, but if somebody forgets or someone misconfigures the system, you're completely vulnerable, right? It sort of flies in the face of what everybody is working towards with cloud-based infrastructure.
Tell me if I'm oversimplifying this, but earlier you were saying, the when all these IoT devices were coming out, it's like the easy part is kind of connecting everything. The hard part is kind of managing all your devices. Is that kind of a similar problem where it's easy to connect to the cloud, but then actually managing your network? It's like the connection's easy, but then actually managing all these kind of moving pieces is the difficult part.
Yeah, and it's kind of which direction you want to go. Right. I mean, one thing to think about is, it's easy to get to a device on the internet if it has a global IP address, but you probably don't want everything to have a global IP address, right? So, if you hear about the hacks that are happening, right? Let's say that you have, you're an EV station company, right? And you've got, EV chargers that are out there, right? Well, you don't really want those on the internet, right? That's not a good thing, right? I mean, so you don't want that to happen. But that's the way that internet works, right? You want to go to a website, it's going to a public global IP address. And so the challenge becomes, if you have all these devices, sure, they can phone home. Sure, they can send data to some public IP address. But now you want to turn it around and you want to communicate with those devices. Well, one, that's probably the absolute wrong security model. But two, it sort of becomes very, very difficult. It's like, well, how do you track all that? How do you make sure all that works? How do you make sure that every endpoint is secured? Because usually security means I got to buy extra equipment for that. And that doesn't make a whole lot of sense. And the interesting additional layer for that is mobile networks. Mobile networks obviously have the most edge devices on them anywhere in the world. But because of that, the carriers were smart. They said, oh, you know what? There's not enough IP addresses in the world to solve this problem. And so they invented something called carrier grade NAT, which is network address translation. So every carrier offers a private network. And so, like, if your iPhone or Android phone connects to a cellular network, chances are it actually doesn't have a global public IP address. If you end up doing an IP lookup on your phone, you might discover that it's in some city, some state, even some country that you're not in, because the routable address is in their data center. The problem with that, though, is that means, like, if you have a VPN endpoint or if you have an IoT device, you can't reach it. It's not possible to do that.
So you mentioned recent hacks, and one that's been in the news is this Verkada hack. Could that recent hack of Verkada, which offers, facial recognition and security camera systems, I'm guessing through IoT devices, could that have been avoided if they had used something like Remote It, and how?
The fundamental thing that we do is we allow you to take advantage of TCP/IP's own built-in security measures. So what happens with the TCP/IP protocol is the reason it's been so pervasive is that it assumes trust. And what that means is, so like if I say, hello, Oleg, you will say hello back, right? And so that's how the TCP/IP protocol works. The problem with that is that means it's very easy for robots to scan the internet and discover these things. And so if you go to a website called Shodan, SHODAN.io, it's essentially Google for the Internet of Things, right? So the hack that you mentioned and almost every other hack happens because all these devices are open. Now, they're either open on the internet or there's some place on the network that's open on the internet. And then once you're on the private network, guess what? It works the same way, right? And so you can scan all the addresses in the LAN very easily and discover these devices. Now, what's interesting about the TCP/IP stack is it actually supports a third kind of IP address, and that's 100% of the IP addresses, and that's called a local host address. And it's unique because it starts with 127. And what 127 addresses are is they're not routable across the internet. So like if I told you that, my security camera home has an IP address of 127.0.0. There is no way for you to be able to get to it, because if you type that onto your computer, the address will go to your computer. It just works that way. And so what our technology does is it allows you to say, oh, I have a web server, I have an SSH server, I have a data storage. You can say, instead of making it available on a public IP address, make it only available on this personal IP address. And what that means is that if you've done that, now if somebody actually breaches your network and they conduct a scan, they can't find it. It's invisible. It doesn't exist. And to me, that's the best way to go, because if it doesn't exist, it's kind of like going back to my analogy, right? Like, if you came to my office and there were no doors and windows, there's no way for you to get in. And so that tends to be the best way, we think.
Okay, so let's talk about the market next. What are the major drivers in your market, and just tell me about the addressable market that you see?
Well, the good news is the addressable market is really, if you think about the internet today, right? The internet started with public websites. And absolutely positively, public websites should be on the global public internet because people want to get to their websites. But for every other single asset that you have that's not your public website, we don't think it should be on the public internet. And so that's our addressable market. And what's interesting about that is, for businesses, that might be servers that service their intranets that are still at AWS. But right now they have global public IP addresses. It could be if you are a company that makes EV stations and you have lots of EV chargers that are out there that are all network connected. You don't want those on the public network. You want to be able to have those privately managed. If you're deploying base stations all over the world, you don't want those on the public internet because the simple answer is you don't want any of those things breachable or hackable. So of course you want them only available to you. And so, those are, fortunately for us, not only, our addressable market, those are some of representative of some of the customers we already have.
Next, talk about your vision of becoming the AWS of networking.
Yeah, really same sort of idea. If you think about AWS, obviously AWS now is everything for everybody. But,
Mhm.
much of how it started was with S3, right? Storage, because they were the first to really realize that, well, storage needs to be available. It needs to be available and scalable everywhere. You don't want to just have to buy hard drives for that. And so that was kind of foundational for them. And, everybody started to realize, oh, you know what? Infinite storage available in the cloud is a good idea. And then from there, they were really able to branch out from that. Everybody has a network today, whether it's a corner grocery store, almost every house today, anywhere, everybody has a network today. But it's very much managed by a piece of equipment that is terrible, honestly. Every router is just terrible. And so we really view that networks absolutely positively should be managed. But the truth is, if you don't have a unique piece of software, right, to be able to generate and manage all these things, it doesn't really work well. And so we think, number one, networks absolutely positively should be managed in the cloud. But unless you have some pretty clever technology, it will be pretty hard to be able to do.
So I don't think anyone's going to disagree with you that the hardware piece could be better. We all deal with kind of connectivity issues and network issues, and they kind of pop up here and there. And I don't really understand what's so bad about it. So can you tell me, like, is it the hardware? Is it the software on top? What is lacking with these modems and hardware devices today?
It's really more that it's not universal. And so what happens is, like, for example, right? You have a network at home, I have a network at home. They might have 100% the same addresses. So, like, everybody who ever bought an Apple router, their network address range is 10.0.0.1 through 255. And so, guess what? It doesn't work, right? It's not routable beyond the network. You can't manage it that way. You can't really touch those devices, even if you connect to it. And this whole idea of virtual private network, it sounds like a brilliant idea, but it's not. All it is you get to connect to your home network. That's it, right? Or you get to connect to your office network, and that's it. And you still have to use those 192.168.1.x address. And it doesn't mean anything to anybody. Even if you're an IT expert, somewhere terribly, you have to have a spreadsheet that says, what does this address point to? And what services are available on that? Now, flip that around and think about how the internet works, right? I mean, the internet's very different. You can remember IP addresses. You don't have to remember IP addresses. You just know some names and URLs. I mean, I'll give you one that maybe is much more relevant to what's happened with COVID. So, what happens if you have a server at AWS is that you have a global IP address, you have an open port, and the way that you usually manage security is something called an IP access list. And what that means is you say, oh, but only allow these addresses to access this website. And that worked great when you were giving access to a building, right? So, hey, our 50 developers in this building, so we're going to allow this site to do that. Well, what happened with COVID is that everybody started working from home. And so all of a sudden now, over the last, now 12 months, almost every company's IP access list has become unmanageable. Because what happens is, you know, at most home networks, their IP addresses change all the time. Or maybe somebody wants to use a cellular router. Well, now all of a sudden you've IP approved AT&T or Verizon, not just, that one developer. And so this one thing, which sort of worked as security because you would access and or authorize buildings, no longer works at all. And then what ends up happening is, a developer goes to an Airbnb and works. Well, they call their IT person in the middle of the night, says, "Hey, I can't access this," and so they have to do that. So imagine on Instagram if your followers had to tell you that they moved, and could you update their IP address so that they can still follow you, right? That's what you have to do if you have a server at AWS today. So one of the things that we're really trying to do is really take a lot of these much more modern approaches, like the equivalent of sharing, the equivalent of followers, the equivalent of following, and really leverage this brilliant UX that now exists on the internet, apply much more pragmatic security to that, and make it much more usable. Because the truth is, the old systems are pretty old, and I don't think will survive scrutiny. And you're already seeing that with the hacks and the breaches that are happening today, because that is the unfortunate reality. Is the reason those hacks happen is it's working as designed.
So who else is doing this? How competitive is your addressable market, and do you see people kind of working on this solution as well?
A lot of people are obviously looking at being able to solve this. I think the unique thing for us, and the thing that we're hopeful that will let us break out through this, is that networking is fundamentally peer to peer. And so we have technology that allows everything to be peer to peer. The only other way to solve this is that you essentially run everything through a cloud. And so when we work with enterprises, they like our solution because they say, oh, everything's peer to peer. Only we can have access to it, and it's never going through your cloud. Competitive solutions tend to be aggregators. So what they say is, we're going to route all your traffic through us, and then you can connect through us. And so it's kind of like if you look at things like Google Photos, right? Like I love Google Photos, I use it, right? But everything's at Google, right? And so competitive services like this are similar, right? Somebody will say, oh, we'll manage all your network, but you'll route everything through our servers. Well, we don't do that because our technology allows the customers to control all their access, and it's all peer to peer. So one of the ways that our CTO likes to joke is the remote key technology is like having the longest virtual cable, right? So it's like having Ethernet cables that span the globe, and you can just connect all your equipment. It's all yours. All the routing goes through your network.
And in the metaphor, you're the cable, or what?
Yeah, I mean that's how our technology works, right? We allow you to go straight peer to peer. We're at endpoint to endpoint.
Okay, okay, just trying to make sure I understood that. Okay, so this sounds incredible. Let's talk about the team you've assembled at Remote It. Who are the people behind Remote It, and yeah, talk about maybe your approach to hiring.
Sure. The core people at the company, again, three of us previously did iReady, so we all wrote the patent on implementing the TCP/IP protocol in silicon. My co-founder, Mike Johnson, one of the more popular TCP/IP stacks that's used in almost every embedded device. He probably wrote, I don't know, a third of the code for that. So, we always like to joke, we may not be the smartest people in the world, but in terms of the TCP/IP stack, we're pretty smart because if you think about it, no one actually works on the TCP/IP stack, right? It comes for free in every operating system, right? And so it happens just to be a very unique piece of knowledge that I think we happen to have. And we have assembled a pretty good team of folks that span understanding cybersecurity, understanding a lot about the communication protocols, understanding a lot about just intellectual property. And so like many technology oriented startups, we have, I think, a very strong team, a very strong technical team, and the knowledge is really strong in kind of networking and security, which I think that matters the most. And similarly, our hiring strategy kind of falls along that. One, we operate completely remotely. In fact, we've done that since even before COVID. And so that allows us to expand our footprint, right? So, we have developers in Argentina, we have developers in India, for like a lot of folks may. We also have a team, the Fujitsu cybersecurity team, essentially is our that three of our folks in Japan came from that group. And so, they man our office in Japan. We also have a number of folks in the North Bay of California because there's a lot of networking companies that came out of that, and so that allowed us to bring in a lot of kind of the knowledge base that we think is pretty foundational for what we're doing.
Okay, now let's look under the hood. Describe the essence of the innovation at your company. What sort of sets you apart from, other people looking at this?
I think the biggest thing again is that we understand the TCP/IP stack. So one of the things that we talk about is there's this understood networking model called the OSI model, and it's kind of 7 layers of the network stack. And most people think about internet functionality at layer 7, which is the application layer, right? And so, that's where a lot of this kind of measures would exist. The key difference is that we operate at layer 3, right, which is down at the network stack. And what that means is that number one, we've done the security there, right? So, again, there are no doors and windows, so you can't get in, right? Because we've closed that door to begin with. But at the application level, the beauty is that you don't have to change anything, right? So if you have any piece of internet software written today, it talks IP address and a port. And so, it can be a global IP address, it could be a local, a LAN address, but it can also be a localhost address. So, if you have a website and it usually runs on a global IP address, well, you can run that website now privately on Remote and it just works, right? You don't have to change any bit of code. Whereas, a while ago, GE did this whole system called Predix, and the challenge with Predix was that it was a great system, but it again, kind of like what we talked about before, everything ran through their cloud. So guess what? You needed a software team to take all of your applications and port them to that platform, right? And software is just hard to do. Whereas with our solution, we're just giving you a different IP address. So 100% of your software is just going to work out of the box. It's now just protected. It's completely secure.
This is really interesting, complex stuff. But let's keep going. What are some of the key milestones that you've achieved on your journey, and where do you stand today?
Sure. The biggest thing is that we've been focusing on really, what are the important use cases and can we work closely with customers? And so we're fortunate enough that, SoftBank, they operate a mobile carrier company in Japan. And so they're one of our partners. In fact, they led our Series A. And they sell to their customers our solution, right? And so what that allowed us to do was really start working closely with a number of their enterprise customers for things like, building automation, for things like, remote is used in train stations and on trains today. Things that fundamentally have networking now need networking, but absolutely positively need to work securely. And so as a company, what that allowed us to do was understand what their use cases are, make sure that our products are packaged well that way so that they can be easily deployed. So our focus has been, well, let's work with a number of key customers. Let's understand what kind of solutions they need. Um, and then we can make a much more scalable product. And so we're sort of at that transition point today where we work with a number of folks. I mentioned it before, but we work with a very large network equipment supplier who sells base stations all over the world, and they use Remote to deploy those base stations because they can provision them from the central office because it doesn't matter what internet connectivity they have because they can reach it because of Remote. We work with the largest, I think, EV station company in North America, right? Because they manage all their EV charging units, using Remote It. And so what that allowed us to do was we took all that and we said, oh, okay, let's now try to build some more standardized products. So we have mobile apps now, we have desktop apps, and most recently we deployed a whole solution for AWS. And what that means is, so now if you're using AWS and you don't want your servers on the public internet, you can close all those ports and you can just use Remote to access that. So all your developers now can be anywhere in the world. You have no IP access list to manage. They can connect to it, and it's all just done by user IDs, right? So if you have Google user IDs, you can just use that, decide who uses it, and if they leave, just take them away, and it goes away. You don't have to go back and update your spreadsheets or change the IP tables or anything like that because it's all taken care of that way.
Well, it sounds like you built some great relationships with some really interesting customers. I think that's probably a great way to track your progress so far. But do you have another important kind of North Star metric that you are using to kind of track progress?
Well, the biggest thing I think, if you're doing any kind of cloud company is, we always joke internally, it's like how many customers have we signed up while we're sleeping, right? And so that's the metric that we're working towards is, because I think it's a testament to how self-serve had you made your product, right? And so, that's the metric that we're really starting to aim for, right? And we're just starting to experiment with that. And I think with AWS, what I think AWS is 1 million customers, right? So we don't have 1 million customers yet, but we were going to start using that as the important measure of how many people are easily able to sign up, how many devices can come online. Um, those are going to be the things that are going to really matter to us. Where if you are going to be a cloud company, I think the key measure has got to be you don't have to touch every customer and they should be able to onboard themselves without your help.
Do you have any kind of flagpole milestones that you're kind of looking forward to in the next, 1 to 2 years?
What do you mean by flagpole?
Are there any kind of milestones you're looking to achieve in the near future?
I think more than anything else, we want to become like one of the things I always think about is I've talked a lot about open ports, right? And the funny thing to me about open ports is it's an accepted evil, right? If you talk to anybody today, they're like, well, of course, if you want to connect to something on the internet, you have to have an open port. I think it's like the emperor has no clothes, right? I mean, I honestly think it's crazy, right? It's like it makes no sense, right? I mean, it literally is putting your front door in the worst neighborhood in the world. And I think that's going to be probably our most important flagship metric. And so we're starting to work with router vendors who are including Remote It, right? Because, here's an interesting rub today. One of the greatest threats right now for home internet security is Minecraft because there's so many kids that are opening ports at home because they want to share their Minecraft server, right? And most parents don't even realize it. But guess what? If you put a Minecraft server on the internet, it's not quite like a Windows server right now, but it's pretty fast, right? I mean, almost every global public IP address gets scanned hundreds of times a day, sometimes thousands of times a day. And guess what? Now they're looking for the Minecraft ports, right? And so, I it's gonna, we're definitely going to come to a point sooner than later where people are going to go, open ports is a really bad idea. I'm honestly shocked that it's still considered a good idea. And so, I think paramount to our success is making that a reality. And so it's probably more of a bellwether milestone, but once that religion becomes accepted, then I'm fairly certain that we get to ride that tidal wave to success.
That's fascinating. I'm wondering if there's any other kind of good examples that come to mind of kind of open security issues, and mostly ones that kind of affect homes, right? Because we've talked about your customers being these like enterprise solutions. I'm still kind of figuring out how remote it fits into like my life,
Oh no,
on
yeah,
my home.
this happens all the time. I can tell you, like I said, if you go to shodan.io, you can, if you sign up for an account, right? Like you can search your zip code for people's open security cameras. People have no idea. I mean, that is the sad thing. I mean, if you have any service provider in the United States today, their routers allow you to open ports, and there's no warning. Doesn't tell you anything, right?
Yeah.
And I'm not gonna throw them under a bus, but there's a very large gaming company. If you go to their website, they specifically say, "Oh, open all these ports on your router." It's like you have literally said, "Make it your internet your personal home network exposed to the internet." But they literally say this. I mean, the level
Yeah.
of absurdity to this is crazy. Now, what's interesting about that is the only way the service providers are gonna be able to unilaterally solve this is to make it impossible, right? So I mentioned before how the mobile carriers have this thing called carrier grade NAT. And so it's impossible, right? Because you cannot open a port. Like if you do a search, I'm trying to share my Minecraft server on my Wi-Fi hotspot. It's not working. It's because it's not possible. It's literally impossible. So, one of my theses is that one of these days, there's going to be too much liability, and Xfinity and Charter are just going to say, "Oh, forget it. We're not going to give you a global IP address anymore." Right?
Mhm.
And so
Mhm.
guess what? The minute that happens, anything that had been available is no longer available, right? And so now, fortunately for us, you'll need a solution like Remote It, which allows you to get access to that, right? And again, part of the reason that the carrier group at SoftBank loved our solution is exactly that. They're like, oh, we have a lot of companies that we're working with that no longer want, for governance reasons, to have an exposed global IP address. So they want to switch to, CGNAT, a carrier grade solution, because it eliminates that threat. But then what they discovered is that things like VPNs don't work anymore because they're not addressable, right?
Mhm.
But if you have an existing VPN infrastructure and you just replace that global IP address with a remoted address, one, it's still very much private, but 100% of it works without having to change anything.
So how are you reaching customers? You mentioned like eventually things are going to get so bad, like the liability is just going to be so huge that people are going to want to change things. But I imagine, you're a proactive guy. You're probably not trying to wait for things to get so dire and terrible. So how are you kind of reaching customers and sort of approaching them with the solution that you know that they need?
Well, so far, again, we've kind of worked closely. So, like in the case, obviously, SoftBank has a sales team, so we've been able to kind of piggyback on that.
Hmm.
Otherwise, it has been somewhat organic. What we've done very conventionally, I suppose, from a technology company perspective, is our solution is available in the standard repo for the Raspberry Pi, but it turns out that almost every enterprise company now prototypes on a Raspberry Pi, and so many of our large companies have come because they prototype their solution. They're like, "Oh, what's this? This works." Um, that the large base station provider that I talked about, we literally never even talked to them until somebody from their purchasing department said, "Hey, we need to buy a license." And so we've been working, by having the solution available pretty openly on a lot of platforms. That's helped itself. Now, what we're starting to do now is we finally, because we have the AWS solution, we're starting to market because we think, a much more identifiable marketplace, right? Anybody who's using AWS. And so now we're going to start some
Hmm.
campaigns directly to target, people who are likely either developers or people that have to worry about, managing the network or security around their cloud instances. And we're, going to promote directly to them.
Yeah. Well, luckily everyone's moving to AWS, and that should be a pretty large segment
Well, that's
of
what
customers.
we're hoping. I mean, I'm a big believer that you want to have an unnatural act to get your scale, and obviously if you can be part of the largest scaling engine that's ever happened, which is obviously AWS, it's probably not a bad thing.
Yeah. All right. Next, tell me how you make money. What's the business model here, and how are you charging your customers? What's your strategy?
Yeah, so we're very much a SaaS company, and typically because you are worried about endpoints, what we do is we just charge a subscription based on the number of endpoints that you want to make available. And so, if you have a number of devices, you obviously just pay a subscription for those devices, and then it just has to do with what kind of access do you want. If it's support, and you don't need to connect to them all the time, it's obviously much more affordable than if you are using cloud instances and you're connecting to them all the time. And then on top of that, what we have is, I guess, what I would consider a very conventional SaaS type model, where depending on the number of users and what kind of privileges you want to give to them, you pay for those users as well. Where admins, are obviously a higher fee, and then standard users would be less. And then we also allow for free guest users. One thing that we do is for personal use, we make the service available. And so, one, we're trying to be thoughtful for any poor parent whose child is exposing their network on Minecraft, because we'd like that service to be free, and we'd like to
Yeah.
be kind of the good policeman for that. But
Mhm.
also, but what we found very pragmatically is that a lot of developers do a lot of stuff at home, and so if we make it free and available to them, like many internet technologies, they'll love it, they'll embrace it, and then they'll bring it to the office place, and we've already seen that sort of pattern repeat itself.
Yeah. Okay, so we're kind of wrapping up here. So looking forward, what are some of the biggest challenges that you still need to address as a company?
I think our biggest challenges, kind of in order of dominoes, would be, we want to reach a larger market, kind of as you identified, you know,
Mhm.
so, how will we reach that audience? How do we make sure that, the solution to becomes much more obvious, right? Like, I sat here and talked for the last 45 minutes about how obvious it is to me, but it's not obvious to the world yet. And so, we have a marketing challenge to make sure that, to me, it's sort of like, you know, 5 years ago, most websites didn't have SSL, right? Like, but now anybody knows that if you don't have that lock or if you get the browser warning, it's a bad thing. Um, I believe that open ports needs to follow that same sort of governance. And so, we have to figure out how to make that message get out there, because we do 100% believe that we have the best solution for it. And so, a combination of, let's make sure that we have a great, self-serve, easy to use product, which I believe we already have, and get that out there with, look, if you're using any device on the internet today, don't leave it exposed. Getting that message out there will matter.
Yeah. All right. Well, this is kind of the last question here, and then we'll wrap up. This is Angel Nears, the podcast for entrepreneurs, innovators, angel investors, engineers, and so we kind of cater to people who are entrepreneurially minded. You're a CEO. Can you tell us about two moments? Your biggest moment of joy as a CEO, and then your biggest moment of despair as a CEO.
Well, let's see. Biggest moment of joy. I think always it's when you're pretty excited about somebody using your solution, right? And it's sort of unexpected, right? That's always a great piece of joy, right? Or, you know,
Mm-hmm.
I'm very much a technology entrepreneur, right? So it's when somebody figures out a much cooler use case for your solution than you ever did, right? And so, we had a number of folks that make, what do they make? They make smart power walls, right, or power, stations, and they're like, oh no, we use this feature for this way, and what they did was they customized how it works with AWS so that it was much easier for the developers to do it. And that's not a common case kind of thing, but I just thought it was so cool because it was like, wow, that's a much better use case than I ever imagined. The downside is, the worst case for me is simple, because I ran a company during the dot com era. So March 2001, I guess, or 2000, whenever the crash was, that was a terrible day. you know, we all had a terrible day during that era. So, but to be honest, I mean, ironically, trying to run a company during the dot com era was pretty terrible too, because it was impossible to hire anybody, because everybody felt like you know, there was a pot of gold at the end of the block, right? And you'd have people come in, work for half a day, and leave, never come back, right? So it's kind of nutty. So
Well, now that I think about it, yeah, if it was March 2001, it's been 20 years, so you've probably made it past that, and you're on to bigger and better things.
yep.
Anyway, before we get out of here, what's the best way for listeners to reach you and remote it?
Sure. Well, obviously the website is Remote It, so it's remote.it. So, we're not an Italian company, although it is an Italian domain, but it is Remote It, and that's probably the best way to reach us. And we have some contact information up there. Anybody wants to reach me, I'm pretty open about that. So it's Ryo, it's RYO at Remote It. Feel free to email me with compliments, praises, or even criticism.
All right, awesome. Well, we're going to end the show there. If you enjoyed it, please subscribe wherever you listen to podcasts and leave us a rating, 5 stars, please. Thanks, Rio, for joining the show today. It was complex, and I'm going to have to go back to relearn it. I really am excited to go back and listen to that. So, thanks for joining the show. Thanks for sharing your time, and thanks for sharing your knowledge. It's been fascinating.
Well, thank you for having me on board.